Good morning or afternoon, whatever the case may be for you. Today we're going to be going over rules of exponents, and this is theoretically a review for a lot of people from Algebra 1, 2, but may not be for other people. So what we're going to be working on today is, we're just going to go through them real quick in terms of what they are and why they work. So first off, I wanted to get a little bit of vocabulary in order. This is y or f of x, depending on how it's written, equals a times b to the x. This is an exponential equation. The main part we're going to be focusing on is this b to the x. But just to start us off, you won't need this until next time. A is the starting point. I don't know why my pen isn't reacting. The main thing, as I said, that we're going to be focusing on today is this b to the power of x, and what that exponent, which is that right there, so that's our exponent, b is our base. So what we're doing today is figuring out why a bunch of these different exponent laws work the way that they do. Exponents have certain properties. The main thing you need to know about the exponent is it's not a numerical value so much as it's an instruction. The exponent tells you how many times to multiply the base by itself. And that part's important because we get into some where that doesn't really make that much sense. All right, so that's what the exponent does, gives you an instruction. So we're going to go through a few different exponent laws. The first of them is if I have x to the a times x to the b, I'm going to show you an example of why that works, and then we'll go back to what the end of that is. So let's say I have x to the third times x to the fourth. What that does, if I take my x to the third, that tells me I'm multiplying x times x times x. And then if I take the x to the fourth, that's going to tell me that I have x times x times x times x. Now, all I'm doing with any of this is multiplying, so the total number of times I'm multiplying x by itself is 1, 2, 3, 4, 5, 6, 7. So this comes out to x to the 7th. So the rule there is that if I have the same base and I'm multiplying, then I add my exponents. So that's just a trick. So instead of actually expanding this out, I would do x to the third times x to the fourth. I would just take the x to the 3 plus 4 to give me x to the 7th. So we have our expanded version and our rule version. So hopefully the expanded version helps you out with why that works. Our next rule is called the power rule. I might want to write that up here. This is the multiplication rule. So the power rule tells us that if we have x to the a to the power of b, what we're going to do is multiply those two exponents. That's the x to the ab, or a times b. So if we look at why that works, let's say I have x to the second to the third power. That third power tells me I'm taking x to the second and multiplying it by itself twice. Now I could multiply, or I could extend this out to be x times x and x times x and x times x, but I have the previous rule to get around that as well. So this would end up being x to the 6th. That's not what I meant, right? There we go. So if I go back up to my example, x to the 2 times 3 is basically just our faster way to do that. So all these rules, it's the expansion that shows you why it works, and then the actual rule that just makes it faster. Because if you have larger things like x to the 5th to the 10th, you're going to have a lot of expanding out to do that's going to be really obnoxious. Go on, I'm going to do this on the other page. So the next step, I'm going to have the quotient rule. And that is, if I have x to the a divided by x to the b, keep in mind we always have to have the same base here, otherwise it doesn't work. That is going to equal x to the a minus b. So if I have x to the 5th over x to the 3rd, and I expand that out, I've got x times x times x times x times x. So that's x to the 5th on the top, x to the 3rd on the bottom. Then what happens is each of these pairs starts to divide out. And the reason it divides out is anything divided by itself is always going to give us 1. So that gives us a 1 times 1 times 1. And a lot of people will talk about this in terms of it canceling. But I don't like to use the word cancel just because a lot of times people think it just disappears. But what I really have here is 1 times 1 times 1, which is just 1. And then x times x, which is x squared. So really that's just x squared. Understanding the 1 part is important because the quotient rule kind of brings us to negative exponents. Oh, I forgot the other part, sorry. So the shortened version of this would be x to the 5 minus 3, which would give me x to the 2nd. So that's my other route to get there. Faster route, I would say. So, sorry about that. So this brings us to the negative exponents and what we know about that. I'm going to show you the y on this one before I show you the rule. So let's say I have x to the 3rd, and I don't know why my color switching is a little bit arbitrary right now, so don't worry about it, over x to the 5th. So I can expand that out. So I've got 3 x's on top and 5 x's on the bottom, and I have very similar results as my previous example. So those divide out to 1, divide out to 1, divide out to 1, and I've got x squared left, but it's on the bottom now. So all these 1s, that were created here, the 1 times 1 times 1, that needs to stay on top of the fraction because that x squared, if it's on the bottom, it has to stay on the bottom. So if I look at this in terms of my rule, x to the 3 minus 5, that gives me x to the negative 2. So anytime I have a negative exponent, so x to the negative a, that is going to be equal to 1 over x to the positive a. So anytime we're simplifying, we want to make sure to simplify without negative exponents. All right, the next one is the 0 exponent. And the reason for this is very similar along the lines of the quotient rule. So let's say I have x to the 3rd over x to the 3rd. So if I look at that expanded, I've got x times x times x over x times x times x. That divides out to 1, divides out to 1, divides out to 1. All I'm left with is 1. I have no x's left. And so if I look at this in terms of my rule, my quotient rule, this would be x to the 3 minus 3, which would give me x to the 0. So what the 0 exponent rule is if I have x to the 0 power, that will always equal 1. Any number to the 0 power will always give me 1. So that's an important thing to understand as well. And all of these rules, as you go through them, what you really, the more you understand them, the less you have to memorize them. So if you try to memorize them, it's really easy to get different rules confused. It's really easy to think something to the first power gives you 0 or vice versa. And so it's really important that you understand how they work, and that way you don't really have to memorize them. So the last one I'm going to hit, and it's a little bit less important, is fractional exponents. And this one's a little bit harder to explain, but we've used this before. And I just ran out of space. So if I have x to the power of a over b. So one of the things, so this why it works is a little bit trickier. If I have x squared and I put that to the power of 1/2, I multiply those two exponents according to the power law, which gives me x to the first, which is just x. And if we think about it, the way that we normally get from x squared to x is by taking a square root, because the square root of x squared is just x. So this right here is actually a square root. So fractional exponents are actually a type of root. So if I have x to the third and I put that to the power of 1/3, that's the same as the cube root of x to the third, which is just x. So when I look at this in terms of how I generalize this, in both of these cases, that top number, that 1, the 1 happened to be, let's see, think of how I want to write this. So if I just have x to the 1/4, this is going to be the 4th root, the equivalent of the 4th root of x. So this 1 has to go somewhere, and where it actually lives is right there. So if I have, if I'm simplifying, not simplifying really, but if I'm writing this as a rule, this is a b root of x to the a. So if I have x to the 2/3 instead of 1/3, that's going to be the cube root of x to the second. Now, how much that actually helps us is pretty limited, but it's important to understand. So real quick, I'm going to do one more quick example of simplifying using all these things. So if I have, let's say, 3x to the third, y to the 4th, x, and then I've got 6x to the 2nd, y to the 6th. And I need to simplify that using a combination of the rules that I know. The thing that I need to remember is that my exponents and my exponent laws, I don't know why this isn't working, my exponents, those are dealt with differently than my coefficients, because 3/6 has nothing, they're not exponents. We're dealing with them as we would anything else. And since we're multiplying all across the top and all across the bottom, we can kind of move these things around. So on the top, I'm going to go ahead and leave my 3/6. But I want to deal with this x and this x. Remember that this is just x to the first. So if I use my multiplication rule, I'm going to make that x to the 4th. And then I'm going to leave the y to the 4th. And then the bottom is already simplified, x to the 2nd, y to the 6th. So then I can kind of split this up. So I've got my coefficients, my x's, and my y's. And if they weren't in that order, I could change that order a little bit. So that's going to come down to 3/6 times x to the 4th over x to the 2nd times y to the 4th over y to the 6th. And then I can use my quotient rule, and I can also, so I'll skip over the 3/6 right now. X to the 4th over x to the 2nd, we subtract 4 minus 2, so we get x to the 2nd. And then the y to the 4th over y to the 6th would be y to the -2. But I want to simplify without any negative exponents. So I'll get to that. We're in a little bit weird order here. But the 3/6, I'm going to leave that as a fraction. I can't do anything with that except for reduce it. And 3 over 6 reduces to 1 over 2. So now if I put this back into fraction form, I'm going to take this one down and put it on the bottom and make it positive. So I've got x to the 2nd on the top, and I've got 2y to the 2nd on the bottom. It was maybe a little bit more complicated than I needed to get, but it's important that you understand that the exponent laws only apply to the exponents. They don't apply to the coefficients. So that's that for exponent laws. And hopefully that'll catch you up on that part. Have a good day.